Hello, college biology. Welcome to electronegativity and ionic bonding. First, we need to describe electronegativity. It is a property that all atoms have, and it is defined as the affinity for electrons of that atom. And affinity is just a fancy word for means how hard is it able to pull on electrons. And I say it's a property that all elements have, and but that's kind of tricky because the noble gases have a special consideration, and we'll talk about that in a minute. First of all, electronegativity is a balance. If it's the ability to pull on electrons, you have to look at what in the atom is going to be helpful for pulling electrons and what in the atom is going to impede that. And it turns out that what helps an atom pull electrons is the number of protons it has. The more protons it has, the more attractive it is to the electrons, the more it can pull those electrons toward it. But there's a flip side. The electrons have to pull through space, and electronegativity or electromagnetism only works under pretty short spaces. So we have to consider what would stop a proton's ability to pull on or attract an electron. Well, the atomic radius. The larger the atom, the more it has to pull, the more distance it has to pull. And so what increases atomic radius? There's nothing like adding extra electron shells. So electronegativity, the atom's ability to pull electrons, is the balance between the number of protons it has pulling and the number of electron shells it has repelling further electrons. And that somewhere it comes to a middle ground where you stop pulling and you stop losing electrons. The reason why the noble gases are special are because they are at that balance point. The ability of the protons are able to hold a certain number of shells of electrons, and the noble gases are at that level. They can't gain any more electrons because their protons can't pull through their electron shells. And the flip is true. Their protons have such a good hold on those shells that anybody that tries to take electrons from them fails to do so. So noble gases, balanced electronegativity. Now for us, we care about our elements of life. So let's take a look at this trend. We know that as we go across the periodic table, we go from boron to carbon and carbon to nitrogen and nitrogen to oxygen, what we're doing is we're adding protons. So as we go across a row, we gain electronegativity. But when we go down a row, we're adding electron shells. So we go from lithium to sodium, we're adding an electron shell, which takes a big hit in electronegativity. So to go up again, we'd have to keep adding protons. And so all of these elements have their own balance of their number of protons and their number of shells, which gives them their electronegativity. The highest electronegativities are going to be over here in the upper right, the lower or in the lower left. So if we look at our elements of light, we have oxygen, nitrogen, those are our highest. Carbon, sulfur, and hydrogen are moderate electronegativities, and phosphorus is low for our elements of life. Now, electronegativity explains bonding, and there are 4 bonds that we're going to discuss. The first is ionic bonds. So in an ionic bond, we have always an element of high electronegativity and an element of low electronegativity. So let's take a look at this. In this example, chlorine is our high electronegative atom, and sodium is our low electronegative atom. And so chlorine is going to be able to pull through its electron shells and from another atom's electron shell, its outer electron shell, and take that electron from it. When it does, it gets a full shell, and it is no longer able to pull any further, so it stops. And sodium, once it loses the shell, it's able to hold on to its first 2 shells very tightly, so it stops. So in this example, there's only 1 electron that's being transferred. Well, what happens when electrons are transferred? Well, once sodium loses an electron, it has 1 more proton than its number of electrons, so it has a positive 1 charge. And chlorine, now that it's gained an extra electron, it has 1 more electron than it has protons, so it has a negative 1 charge. And now we go back to our electromagnetism. The positively charged cation is attracted to the negatively charged anion, and they come together to form an ionic bond. So here, a high electronegative atom and a low electronegative atom came together to form an ionic bond, all because of their electronegativity. Let's review. Here we are. Electronegativity is an atom's affinity for electrons, and affinity is just a fancy word for their pull on electrons. A high electronegativity indicates a strong pull. It is a balance between the number of protons in the atom attracting electrons and the number of electron shells interfering with the attraction. For our elements of life, oxygen and nitrogen have a high electronegativity, sulfur, carbon, and hydrogen have a moderate electronegativity, and phosphorus has a low electronegativity. Ionic bonds will form when a high electronegative atom is close to a low electronegative atom. The high electronegative atom will pull hard enough to remove electrons from the low electronegative atom. And they'll continue doing this until the high electronegative atom fills its valence shell of outer electrons, or the lower electronegative atom empties its valence shell. Having gained the electrons, the high electronegative atom has a negative charge. Having lost electrons, the low electronegative atom has a positive charge, and opposite charged ions attract, forming an ionic bond. I would like to say that I'm going to change this to gains a negative charge. Oh, no! And becomes an anion, because we want to learn those terms. We want to use those correctly. And the low electronegative atom gains a positive charge and becomes a cation. And then, of course, opposite charged ions attract, forming an ionic bond. I hope this helps. Struggle well.